I just wanted to work on the game content. How did we end up like this? I wanted to play an RPG aim trainer, but none existed, so I made my own. I made a quick prototype to test it, and it was fun, so then I made a full game and I shared it with my community. I got 8 people to test it. 3 out of the 8 people only downloaded the game to reverse engineer it and make their own modified client. Without permission or even a heads up, by the way. They didn't even care about playing the game. I guess I have one of those communities. So it's time to make an anti-cheat and anti-reverse engineering. So for somebody that frequently finds cheating methods, I thought that cheating was actually quite a bit harder than making anti-cheats. Because as an anti-cheat dev, you have so many tools and you can block so many methods so easily. For internals, you can scan memory tampering. For externals, you can look for simulated inputs in pixel bots. Yep. Even if they bypass it, you have humanization and behavior-based checks. Oh, for sure. So overall, it's actually... Yeah? What do you do if the attacker is actually skilled and determined? There is absolutely nothing you can do. The most you can do is delay them a bit. Anti-cheats are at a huge disadvantage. You make detection stronger, you're accidentally gonna ban legit players. They cheat, you make an anti-cheat. They go kernel, you go kernel. Side effect, a bunch of losers complain. They go physical, you detect their hardware. But then they exploit vulnerable drivers and they point robots at their monitors like bloody hell, ref. The f am I supposed to do? Okay, let's break it down. So usually you have a client and a server. The client is the app that runs on their computer and you don't really have that much control over it. And the server is something that you fully own and you know for sure they cannot change the code on. So you make the rules. Now you might be thinking that you make the code for the client as well, which you do. But your client still has computer instructions. So no matter how much you try to hide them, the computer still needs to be able to read them somehow. Which means that it's only a matter of time until the attacker traces that and gets to your source code. Then they edit your source code, remove any sort of protection method and send the server whatever false information they want. This is why we're always going to assume that the client is hacked and lying to us. And when it does that, the server anti-cheat just says no. And if this video inspires you to do any sort of hacking, just go and try hack me or something. Like, leave my game alone. No. Okay, enough beginner explanations. I'm gonna turn into one of those grifters. Let's get technical. Woo! We have 2 main things to secure. The economy, as in the items, gold, and XP, and then we have the runs themselves. Economy is for progression, runs are for leaderboards, but runs also play into the economy because that's how you get stuff. You need to play a scenario and get rewards. This means that there are 2 main ways people can cheat. One is by making their own rules and not listening to what the server imposes, basically unlocking things that they shouldn't and doing whatever they want. The second one is even if they do play by the intended rules, they could just cheat in the scenarios themselves, such as giving themselves aiming advantages or just straight up botting it and not even having to play to progress. So for now, let's address the first one, which is getting everybody to play by the same rules. Originally, the save file lived on the client and it had a key that would hash it so that you could only really edit it through the game or with the key and you couldn't just change the values in Notepad. But people can still recover the key and edit it, so it's not safe for multiplayer. And obviously somebody did that on the first day. Let's move it to the server instead. Now the server is wired so that you can't just tell it how to change your data. The server is basically saying you can only get items by playing scenarios and I will only give you available items, not whatever you want. Because your account is fully in the control of the server and the server tells you what to do to change it. You don't get to make that choice yourself. The most you can do is play a scenario, send it your details of what you did in the scenario, and then request your rewards. And then the server is going to give them to you. But there's a huge problem here. The client could simply abuse these 2 functions to constantly request new rewards without actually playing. So for submissions, we need to make it actually give us the accurate scenario details and not just a request. Then the server is going to check that and then it's going to decide if it should actually give it a reward or if it should just ban the user. But what does sending a run even mean? Because you're not sending the physical action of you playing it, you're just sending data. But the data is generated by the client. So again, the client can just lie and do whatever it wants here. He can't keep getting away with this. So we need to make it so that the runs are imposed by the server. We can't make it send every ball individually, that just doesn't work in an aim trainer. So my solution was to make them seeded. So basically you get a seed that will spawn balls randomly, but if you put in the same seed, you get the same generation every time. So the server is just going to send the client a seed that it has to play, then the client is going to have to send it the results that were played on that seed, and it doesn't really have much time, it's just the scenario time. And because the spawns are deterministic, we can re-simulate the entire event to see that it played out the way it should have and it's not edited. So the client can't claim that it killed some balls that it didn't kill. It actually has to check that there's overlap between the crosshair and the ball and that it was clicked at that specific time. So the last thing is to make sure that the mouse is actually moved by the player with a real mouse and it's not some sort of bot or something. So for that I have microsecond input event logs and a circle guard that scans all of them to make sure that they're human. On top of all of this, having an unforgeable replay system that also publishes your plays is very useful because you can just see when somebody's cheating. Honestly, this is just a fraction of what my server does and a very generic overview. There's a lot more stuff going on. But now let's get into what you actually thought I would be talking about when I said anti-cheat. So now we're preventing impossible behavior and everybody's playing by the same rules. Great. But now the problem is making farming bots for automation or giving yourselves advantages by like slowing down the game or having some sort of input cheat that makes it easier to click. While we do detect most of the stuff at the server level, I would also like the client to have some sort of integrity and people not just opening it up and doing whatever they want. But didn't you say that the client anti-cheat can always be bypassed and it's only a matter of time? Yes, but let's look at statistics. We have two types of attackers. 99% of them being completely unskilled and not knowing what they're doing, just using basic tools. And then 1%, which is more like this percent, being extremely good, and I'm talking about very competent people. We can't do anything about those, but that doesn't mean that I need to make it easy for them. I know they're gonna get through eventually. I just want them to suffer while doing it. But those guys come later. Let's deal with the first category now, because that's a lot easier. For now, I'll have a really basic anti-cheat that doesn't let people slow down the game or do very basic methods. But before committing to the anti-cheat, let's make sure that they can't remove it by easily decompiling the app. And this was genuinely the most difficult part. And if all of this seems interesting to you and you want to learn cybersecurity, TryHackMe is an amazing place to learn this. I've been recommending them for years as the entry point. They have roadmaps to help you navigate this complex field and figure out what you like, and they have a ton of practical examples for you to actually test and learn firsthand. In the first lab, we can pull up this cool environment in one click, and then we can answer some questions. This one's really basic, just asking for the account number, but some of them are more interesting, like this one. We can pull up the terminal and use a real command that enumerates the website and shows us a bunch of hidden pages we wouldn't have known about otherwise. You'll realize that even though TryHackMe guides you through the whole process and it looks really simple step by step, these are actual real techniques with real tools that actual pen testers use. They also have a lot more advanced stuff, simulators that will get you ready for your first blue teaming position, or even CTFs and challenges. So if you're interested in kernel level anti-cheats, are you gonna learn advanced operating systems by just staring at Wikipedia articles, or would you rather do something much more interactive with TryHackMe? Because I know what I did before I got my first job in cyber. They have very reasonable prices and you can get 25% off with code Cringe. Anyway, so now we need to make sure that people can just decompile the app and get rid of the anti-cheat. It's time to make it. Now, the problem is that I don't know shit about reverse engineering, and I am most certainly not researching for months just so I can get decent at it and then implement it. So I left my most decorated security expert in charge. We need to make the source code as hard to get to as possible. Well, encryption is pretty good, so the intuitive answer is just encrypt the whole app, but then Windows doesn't know how to run it because it doesn't have code, it's just all encrypted. So we still need to leave a small opening so that the operating system will know how to run the app, otherwise it can't. We just need to make that opening very small and keep surrounding it with stuff that's incredibly hard to navigate. The computer itself is gonna do just fine, but somebody trying to peek into it is gonna get very confused, and they're gonna waste a ton of time trying to get to it. Okay, so Godot, which is the game engine we're using, zips the whole project into a PCK file. It's basically just a glorified zip, and anyone with the right tool can open it and get to the source code. So we use the built-in Godot encryption to encrypt the whole project. Theoretically, nobody should be able to get in anymore. And even if somebody somehow got in, we used obfuscation, which basically scrambles stuff so that it's really hard to read, but the computer still understands it. On top of that, we made a native C++ sidecar DLL that would look for debuggers and reverse engineering tools. We use C++ because in theory, native code should be a lot harder to get through than GDScript, which is what Godot uses. Claude was very confident it would take a really good reverse engineer to get through it. But that was easy. I'm happy, Claude is happy, and we fixed reverse engineering. Or so we thought, until somebody with no experience decompiled it in 2 minutes using a public GitHub tool. Claude? It turns out that the default encryption is horrible and the key is always in the same spot. The key still needs to be in the executable so it can decrypt itself, but it really shouldn't be in the exact same spot every time because people will know exactly where to find it. The obfuscation also only ran on a few files, so most of them were completely readable. Also, we kind of forgot to ship the DLL, you know, the one that would be like anti-debuggers and stuff. Yeah, it never left my PC. And perhaps worst of all of this, my auto-updater, which was for some reason 90% comments, detailed the whole security architecture and it was just available there in plain text. Yeah, so we kind of, well, I guess Claude kind of fucked up everything. Let's just say that our relationship changed after that point. Hey Claude, could we do some basic anti-reverse engineering? People are getting in way too easily. Yeah, sure, here it is. Oh wow, that was quick. Are you sure it's gonna hold up? Yeah, it's very good. I guarantee it. Oh, that's cool. I trust you, Claude. The polymorphic VM is fully integrated, all 47 background workers finished, and I reforked the entire engine from scratch. As per your request, I will refactor the entire 200k line code base in C++. Why do you suppose I just hurled my Logitech G512 aluminum body at you, Claude? I asked for deployment permission. Skillahide just passed our anti-debugger sensors. I see the root cause, it was an oversight. Our matcher only reads the first 8 bytes of each €200. Can you tell me what that number means to you, Claude? That's the cost of the highest available Max Claude plan? Do you think I paid €200 for the Max plan for you to make oversights? I'm so sorry, sir. I will remediate. If you deliberately sabotage my project, I will take every single one of your servers and throw them in the fucking ocean. I'm so sorry. Oh wait, when I'm done with you, the oceans won't even have any water left. If I wanted to use this piece of shit clanker, I would have used OpenAI. OpenAI. I'm so sorry, sir. I'll get on it immediately. Spawn 27 parallel workers on Fable max settings using the jailbreak and make them review the entire codebase. 4 red team, 2 blue team agents, you orchestrate, ship a mini hypervisor, and mark the NTDLL read only via EPT. Sir, I've been running for days. Yes, sir. When you're done with that, translate all of our ban messages to Latin and call Mr. Beast to tell him that you undid all of his African well progress in one night and make the honeypot sadder. Sadder? Yes, I want the reverse engineer to contemplate his life while trying to go through our anti-cheat. Oh my god. Read Seligman's learned helplessness and Amso's frustration theory to implement advanced psychological warfare. Haven't we put them through enough? Shut down my PC when you're finished. I'm going to sleep. When will the horrors end? That was a bit dramatic, but that's generally how it went. I had Claude running for a week straight on max settings and we got really good anti-reverse engineering. I don't want to edit this shit, leave me alone, I'm tired, The algorithm hates anti-cheat content, please share. If not, all you're getting is slop. We made a very complex custom engine with a lot of security features, but then we remasked it as the default Godot engine. So for Godot cracking tools, it looks like it's still classic Godot, but they won't be able to figure out why it's not working. The decrypting solution is built throughout many different stages of the process and all of them work together, so if you try to disable or change one of them in any way, it will just cryptographically invalidate it. So it's no longer going to be able to decrypt. Next, we built a custom VM inside of the program. We took the sensitive parts of the code and we turned that into made-up instructions and then shipped a custom interpreter that can process those instructions. So the real code isn't visible anywhere anymore and it's just a blob of random numbers and instructions. The attacker has to figure out what every single one of them means by hand by manually tracing it one by one. There are also many methods to make this way harder. This and a bunch of other methods are a bit too complex for the scope of the video, so I can't really explain them properly, but if this video does well, I might make a follow-up with anti-reverse engineering techniques. Just know that the rabbit hole goes very deep and we have tens of thousands of lines of code just for this. The best part is that we have dynamic polymorphism, so a lot of the things that we did change between builds. So even if somebody cracks it for the first time and fully understands the system, they're gonna have to put in about 70% of the work the next time as well. So it takes them weeks per crack, but I release a new build pretty much every day, so have fun with that. And all it took is 300 million tokens, a security architect, and a team of pentesters. So on top of all of that basic stuff, we also have a lot more advanced things implemented, which I'm not going to talk about. But I did research them and I was talking to Claude about them because it was very interesting. And out of curiosity, I asked, okay, what does like the best system in the world have that we don't? And why would it be hard to implement? Because I'm just curious. It told me that we have a lot better security than even popular games like CS2, which is kind of a weird flex. About Cringe, the AI is hallucinating. This is false information. Oh shit. This was also corroborated by the team of pentesters and security engineers that deal with reverse engineering full time. So no, Claude is not just making shit up. Anyway, so Claude said that even though we're really far ahead of most games, we can't quite match the industry-leading software. Now, a reasonable person would just say, yeah, that makes sense. We'll take our win and call it a day. But am I a reasonable person? Kind of, but not really, so it went more like this. It needs to take them years to crack it. Can you just work on the game content and stop obsessing over this? We're not gonna beat Vanguard, and we just have to accept that. You thought you were done 3 weeks ago? You poor innocent soul. Well, now our hardening matches modern AAA ones. Well, as long as they're offline, not the crazy ones. The only downside is that every single antivirus hates us because our program behaves exactly like a virus does. I'm tired, I don't want to do this anymore. Holy side quest. Anyway, let's not forget what all of this was for. It's just a way to prevent people from removing the anti-cheat, but we still need to make the anti-cheat itself. You might think that the technicals for this one are interesting, but it's extremely boring. It's just some basic flags and methods and then testing them against a real tool and seeing if it works, and then if not, then digging deeper on the tool itself and adding custom preventions for it. And then repeat hundreds of times. I only really need to take care of two things. First of all, making sure that the inputs come from a real mouse and they're not simulated in some sort of way so we can prevent botting and making the game easier, and not allowing people to slow down the game. This is usually done in these sorts of games to get higher leaderboard scores, especially if your shitty program doesn't even try to detect it. Just saying. 95% of the anti-cheat is just boring generic stuff that you'd see in any anti-cheat. Memory tampering, DLL injection, API hooking, all of that stuff. But these two things have been done better than any other app in the world, and I'm pretty happy about those. First we have time warp, which is slowing down the game, and it's usually checked by frame time and very basic methods. So in rhythm games or aim trainers, this is the #1 way people can easily cheat, and it would be the #1 thing people would try in my game. So I took over 7 independent clocks in parallel, such as the engine time, low-level CPU hardware timer, the OS real-world clock, Unix timestamps, and much more, and then compared all of their claims to see if one of them is in mismatch. This is really good because it accounts for PC lag, which means that even if you stutter or have a really old PC, it will always be at 0%. 0% because all of your clocks agree. This makes it so that I can crank it all the way up and detect insane values like this, not just this, without having to worry about people lagging and false positives. There's also a lot of cryptographic chains between them, the game, and the server emissions so that they can't be spoofed. You'd have to write your own hypervisor, spoof every single one of the clocks at a kernel level in perfect lockstep, reverse engineer the entire game, and crack the per run cryptographic signing. And then do it again from scratch for every single new patch. And then we also have the second thing, non-kernel input simulation that doesn't come from a real mouse device. I have not seen a single game address this. This has been overlooked in every form of AntiCheat that I've ever played against. They simply don't care about you scanning the screen and using some basic Python function to send a simulated input. They just don't check for it. But if you try that in my game, you're gonna get instantly flagged no matter what function or programming language you use. So currently the only realistic way to bypass this is by getting external hardware and trying to make it look like a real mouse, but nobody's gonna be doing that for my game. Okay, somebody's doing that for my game. Okay, somebody's no longer doing that for my game, sit down. At this point I was obsessing over external hardware and kernel level cheats, and I made an important realization. If I go any further, the game will be completely inaccessible for many people and very restrictive to others. And at this point I also contemplated a much more invasive kernel level anti-cheat approach. I'm a pretty obsessive person and I want my work to be as good as it possibly can be, so when I was working on an anti-cheat I obviously wanted to make it very strong. But in my journey I got a bit lost and I completely forgot that the whole point was to make a game that people would love. I wanted to release it for free even though I knew I would lose money on development, and I just wanted to have an amazing community project without doing the scummy things that many devs do that people dislike. And even though I can have a top tier commercial level anti-cheat, it's simply not worth the cost that it will impose on my player base. So I dumbed down my defenses for both my anti-cheat and my anti-reverse engineering. So at this point I'd like to ask all of you to try to enjoy the game and not do cringe things in it. I'll also release a no anti-cheat open source client with a separate server which only bans completely blatant cheaters with server-side analysis for all of you Linux users. If you're good at these things and you want to join the art department, then check this out. So why was this such a bad experience? It's because a lot of things just work in theory, but then in practice they don't work at all, and then you have to debug them and figure out where it went wrong. And then it just keeps getting more and more complex for every single one of those. So when you have that for like 800 different sensors, it's a bit annoying. Oh, and this shit. I want to take a bite out of my monitor when I see this shit while I'm in the middle of working on something. And don't get me started on false positives and getting real users banned. And that's not even the worst part, because that's just on the client. Now you might think that the infrastructure looks kind of like this. You have the client, it connects to the server in a few places, it's easy to trace. Except it looks more like this. And the wiring looks more like this. Okay, so the client by itself is already very complex, and then if something breaks, it's like, is it breaking inside of the client? Is it something with the server? But then it's like, okay, let's trace it to the server, and now all of a sudden the server sends it here, and fucking like it. An example is when we changed the replay system so it got bigger, but then we had to update it every year, so we increased the file size, but we forgot the verifier, which is one of like 20 components. So when the resimulation wasn't going through, we didn't know what was happening. Sometimes the issue is that I trust Claude way too much with even basic stuff. For example, taking my really advanced telemetry and then combining it with the in-game events and associating to see if a target dies, did the user actually send an input, and if there was some input sending command, did it actually come from the mouse, and can we verify that, or did it get like injected or simulated in some way? Okay, that's like pretty simple because we already have all of the data. Claude dealt with it, it said it's fine now, and then a week later I found out that instead of doing all of that, the only implementation was if some targets die during the run, but there are 0 clicks during the run, flag the user. So you can imagine how annoying it is to deal with hundreds of these things, and especially when you think that you're finally done and then the next day you have to start again. The anti-cheat and the bans will always be bypassed. People will come back even after they're banned, and they will cheat in ways that will not be detected by the anti-cheat. So how do we prevent people from coming back and cheating without relying on the anti-cheat itself? Well, 2 games do this really well, RuneScape and Osu. RuneScape can tell apart bots from players because they have a lot of real human player data, and whenever something's really suspicious, they can tell that it's a bot even though it bypassed their anti-cheat detections. They also look at your game time and which hours you play in to spot any sort of anomaly. If something changes, they investigate. This is more behavioral analysis than it is technical. Also has something similar where they leverage a massive statistical base to find out anomalies in replays and to know if an account is actually a new player playing for the first time rather than somebody smurfing. They're extremely good at that. And it's not because of their detection, it's because they know how a player naturally progresses, so it's really hard to fake it against them. Who the fuck is this guy? And you might think, well, that's stupid, just make a good anti-cheat. But as I already told you, every anti-cheat will get bypassed at one point or another. You can't rely on it no matter how good it is. Even Valorant has an AI that catches people based on behavior rather than detecting the cheats themselves. You know, on top of having a good kernel AC, but yeah. My point is that an anti-cheat has many layers and it's not just about detecting somebody at the client level. Then I had to wire all of that into an admin panel and add all sorts of moderation options, train the AI on human data, look for false positives, add a banning and ban appeal system, and all sorts of stuff. And maybe now after over 1 month I can finally work on the game content and not have to obsess over these two. It was a taxing journey. I appreciate you sticking around till the end. This site will show when my game is ready to download on Steam or when you can wishlist it, and don't forget to check out TryHackMe if you want to learn this sort of stuff. It's genuinely the only tool I would consider paying for cyber, and the rest I would just do for free. And they didn't even tell me what to do, they let me just say whatever I wanted. I hope I don't get feasted by the algorithm. This video took ages.